Students, I'm going to work through a few of these problems you can find on page 301 of your workbook to kind of show you how we can find some area of some weird shaped polygons. We're going to start with just reviewing area of a triangle. This triangle, you can tell on page 301, example A, had a base of 4. So I'm going to just label the base of 4. I can tell that from the graph. And it also tells that this is a regular polygon. By regular, it means if one side is 4, all the sides are 4. And since this triangle is equilateral and all the sides are equal, it's also true that if the sides in a triangle are equal, the angles opposite those sides are equal. So if those are 4, each of these are equal angles. So since the angles add to 180, each of those angles would be 60 degrees. So I have 3 60-degree angles, sides of 4. Now to find the area of this triangle, area of a triangle is 1/2 base times height, because the base times the height is the area of a rectangle. A triangle is pretty much half of a rectangle, so 1/2 base times height. So I'm going to need to find the height of this triangle. I'm just going to draw a red line straight down the middle to represent the height. And I can see what I have done is I've just split this triangle into 2 right triangles. So if this altitude that splits that in half, that height, it makes that side of the base 2. I know the hypotenuse of that side is 4 of that smaller right triangle I'm marking here in red, and then I need to be able to find the height. Now, there's several ways I could do this. I could notice on this one it's a 30, 60, 90 triangle, and if I notice that's a 30, 60, 90 triangle, my short side is 2, so this side is 2 square root of 3. If you do not remember your 30, 60, 90 triangles, that's okay, because I'm going to show you another way to do this. And this is a way that will work for anything, even if it's not a special triangle. What I can do is I can say this angle at the top, since it is half of that, is a 30-degree angle. And I can relate this side of 4. And if I call this side here x, I can get the same answer in this other way. So what I need to do is say what trig function relates my hypotenuse with my adjacent side, and what I would be looking for is a cosine. So I'm going to say cosine of 30 degrees equals the adjacent is x over 4. To solve for x, I would multiply both sides by 4, so I'd have 4 cosine of 30 degrees to be equal to x. And at this point, I'm just ready to finish solving this with a calculator. If I wanted to get in an exact form, I would have to know what cosine of 30 degrees was. At that point, I would need special triangles probably. Let's go ahead and pull up Desmos, though. When I pull up Desmos, I can type in 4 cosine of 30 degrees, and you notice it gives me an answer of 3.6. What I always ask myself is that a reasonable answer? That's not a terrible answer since one side's 4, but I want to just make sure that I am in the correct mode on my calculator. So I'm going to hit the wrench and make sure that I am in degree mode. So I am currently in degree mode. That's good. So that's why that was a reasonable answer. Notice if I would have been in radian mode, I would have had a very unreasonable answer. If that hypotenuse was 4, that seems awful short for the long side of a triangle. And so 3.46 is a good approximation. You're like, but Mr. Hass, a second ago, you gave us a different answer. You gave us an answer of 2 square root of 3. Well, if I had that as a multiple choice answer, I can do 2 square root of 3. And notice it is the same decimal. So you can always match and find out the decimals are the same, so it's good. So I can know the height of this triangle is 3.46. Now, once I know the height, this value of x is 3.46. To finish and find the area, I can say the area is 1/2 the base, which is 4, times the height, which is 3.46. So back to Desmos to put that in. I just take my thing there, and I could just actually type it in there, multiply that by 1/2, and then times my base, which is 4. I'm going to get a decimal of 6.93. So your approximate area of this triangle is 6.93.